Good day, 10Cs. Welcome to the last lesson of the first half of this particular chapter, if that makes sense. We've been working with polynomials, adding and subtracting them, added some new stuff to stuff that we'd already had previous knowledge. Well, and we've already done a little bit of this, but we're going to look at doing measurement stuff, areas and perimeters with polynomials. So remember, it doesn't matter what kind of shape you have. If I want the perimeter, I want the total of all the distance around the object. That's a perimeter. Add up the sides. Now, if I'm using polynomials, though, I'm not going to say, oh, 37 centimeters is my perimeter. We are going to have some kind of an expression. Who knows what it is, depends upon the numbers that are given, but we're not going to get nice, simple numbers because we're working with polynomials. We'll get polynomial expressions to represent the perimeter. Same thing with area. And we'll review this, but if I wanted the area of this object, I would want to know all of the space that it covers. Well, in that case, we would have to split it into two shapes, area 1, area 2, get length times width, and get some kind of an expression, plus length times width, some kind of an expression, and we're going to end up with some kind of an expression for the area. It won't be a nice simple area is 12 meters squared. It's not going to be that. Because we're working with polynomials, we are still going to add, subtract, multiply, and divide the sides according to the calculation we're doing. We're just going to get answers that honestly are about the math, not necessarily about practical use. So we actually finished last lesson looking at a couple of these. So here we go again. Areas and perimeters. We're looking at page 24 here. 2x plus 3 and an x plus 5. So in this case, we want to calculate the perimeter and the area. Well, two ways to do perimeter. Either one is acceptable, but one is a little better. If we want the distance around this rectangle, I have two lengths that are 2x plus 3. So I could say I have two 2x plus 3s, along with, because I add up the perimeters, 2 x plus 5 lengths. So that's what I'm going to do to get the perimeter. 2 2x plus 3s and 2 2x plus 5s will get me the distance around. Well, perimeter, I distribute. Because I have an addition sign, I have a monomial times a binomial plus a monomial times a binomial. There's no FOIL happening here because we don't ever have a bracket beside a bracket. 4x plus 6 added to 2x plus 10. Always combine like terms if possible, and our perimeter is 6x plus 16. So 6x plus 16 is the perimeter for this shape. Now, some of you might not want to double the sides. The perimeter, you could also add up all the sides, which means you're just going to add each side twice. There's 2x plus 2 2x's plus 3s and 2 x plus 5s. If I combine my like terms here, I'm still going to get my 6x plus 16. All the distance around. Second part is the area of a rectangle. Area of a rectangle is as simple as length times width. And the area here, we have a 2x plus 3 for length times x plus 5. But we have to make sure all of the length is going to be multiplied. So our length, 2x plus 3 is in brackets, times our width, x plus 5. brackets beside brackets here. Binomial times a binomial. There's no addition or subtraction sign, so it is a binomial times a binomial, which means we require FOIL. 2x has to multiply twice, 3 has to multiply twice, and that will give us the first terms, 2x squared, plus the outer terms, 10x, plus the inner terms, 3x, plus the last terms, 15. So the area, after I combine my like terms, is 2x squared plus 13x plus 15. Areas and perimeters. Not nice, simple, single values like the real world, but we're doing polynomial work, a little bit different. Here we want to calculate the perimeter of this shape. Well, what's tricky about this one is I want the total of all the sides of that particular shape. Total distance around, well, we're missing some distances. So we have to calculate those first. This distance here, all the way across the top, if we take a look, it's made up of those two distances. 3x minus 2 along with the x plus 5 make up that total distance. So x plus 5 plus 3x minus 2, combine my like terms, this length is 4x plus 3. So we get a 4x plus 3 length there. All right? And from there, well, now I want this length here. Well, this length is a little different as well. If I look, I have this total distance, top to bottom. But I don't want all of it. I just want this part here. That's equal to this over here. So I don't want all of 2x because I don't want this part here. So this length could be described as 2x, take away the part you don't want, which is x minus 1. But we want to subtract the whole thing, so we need brackets. So this 2x length less the x minus 1 will give me the length over on our right side. Distribute the negative 1. We have 2x minus x plus 1 because the negative 1 gets distributed. Leaves us with 1x plus 1. There's the length of that side, x plus 1. So sometimes a little bit of calculating for these unknowns before I can get the total perimeter. And now I just have to add up all the sides. X plus 5, x minus 1. Adding all of these sides together. 3x minus 2, x plus 1. 4x plus 3 and a 2x. So this, the math here is not real tough, but the organizing is. There's my x plus 5. I want to add an x minus 1, got it. Want to add a 3x minus 2, got it. Want to add an x plus 1, got it. Want to add a 4x plus 3, got it. And want to add a 2x. I have all the sides I need. Now I combine my like terms. So my like terms, just get rid of what I have here under 9s so I can underline my like terms, which I like to do. And we have 1x and 1x is 2x. And 3x is 5. And 1 more is 6. And 4 is 10. And 2 is 12x. 5 minus 1 is 4. Minus 2 is 2. Plus 1 is 3. Plus 3 is 6. 12x plus 6 is the perimeter of that shape after I find the unknown side lengths. Well, this particular shape, we want the area. Well, we're missing a little bit of a measurement here. Let me bring it back into the screen. All right, so there are different ways to approach this question. We want the area. I'm going to do it twice just to show you that it'll be the area no matter what. When you have an odd shape and you want area, you need to split it up so that you have shapes you can deal with. Area 1, area 2. Well, area 1 is a rectangle that has a length and a width equal to that. So area 1 will be x times x minus 3. Length times width. And I want to add to that area 2. Well, area 2 is 9 by 2. So I just want to go 9 times 2, length times width. If we do the work correctly, distribute the x, because then there's an addition sign, so it's a monomial times a binomial, x squared minus 3x, multiply my 9 and 2, which is 18, and there's the area of my irregular shape. X squared minus 3x plus 18. Now, some people might not see it that way. There's more than one way to approach a lot of these questions. Another way is some people, sorry, I just did it that way. Some people might see it as two big long rectangles. Area 1, area 2. Well, we haven't changed the amount of the total area, we've just changed how to approach it. So again, the area would be area 1 plus area 2. Well, area 1 has a length of x plus 9 and a width of 2. So the area would be length times width, 2 times x plus 9. And my area 2 has a length of x, but a width now only of x minus 5. So x and an x minus 5 have to be multiplied length times width. Addition sign in between the multiplying, so mono times a binomial, and then mono times a binomial. 2x plus 18 plus x squared minus 5x. And when we combine our like terms, 2x, we have the x squared by itself. We have 2x and negative 5x, which is a negative 3x, and then the 18. And we get the same area, which we should, but there's more than one way. Calculate the area, length times width of each shape, area, area, and then add them together. Areas. Not nice simple numbers for answers, but expressions. So here we want to represent the shaded area. Again, different ways to do it. What I would like to see in this case, a little bit different, is I want to look at taking a look at a shaded region. A lot of these questions, we can get the area of the big shape, and then we calculate and subtract the area that's unshaded. So we want to pretend we have this entire rectangle shaded. So in this case, our big shape is a rectangle LW. However, we don't want the entire rectangle because we want what's unshaded. We don't want that top corner. So what would I have to do if I get the area of the entire rectangle? I would have to subtract the area of this then small rectangle that's not shaded. So we have a big entire rectangle, and we're going to subtract the unshaded rectangle. So the big rectangle, what are its dimensions? Well, the big rectangle, if we take a look at dimensions, all the way across is 6x plus 8 plus the x minus 3. That gives us 7x plus 5. So we want 7x plus 5 for the dimensions there. So 7x plus 5 is our full dimension. 7x plus 5. And we need to multiply it by its other dimension, which is 3x squared plus 5x plus 3. Do take a note, and I apologize, I meant to point this out. This x minus 3 in your booklet is x plus 2. Just be familiar with that. I apologize for not pointing that out initially. But still, our big rectangle, 7x plus 5 times the 3x squared plus 5x plus 3. And now we want to subtract the small rectangle, which is x minus 3 and 3x plus 1. So x minus 3 times 3x plus 1. So here we go. There's how it looks. Big rectangle, take away the unshaded rectangle. Here, 6 multiplication steps because it's a binomial length times a trinomial length. So it's not even FOIL, it's expanded FOIL. Double check, watch your small errors. 21, x cubed plus 35 x squared plus 21x. Then the 5 gets multiplied, plus 15x squared plus 25x plus 15. And with that, we're going to have to take all of that, and we're going to have to actually need more space. Now I have to subtract my FOIL calculations for the small rectangle. Binomial times binomial, length binomial, width binomial, we need FOIL. I want to subtract this area. So we're going to subtract 3x squared plus 1x minus 9x minus 3. But remember, we talked about this last lesson. I want to subtract this entire area. I don't want to just subtract the 3x squared. I want to subtract everything, so I need to put it all in brackets so the entire expression is going to be subtracted, because that negative needs to distribute to each value. So that's going to leave us with 21x cubed plus 35x squared plus 21x plus 15x squared plus 25x plus 15 minus 3x squared minus 1x plus 9x, because it's a negative times a negative 9x, and negative times negative 3 is plus 3. Holy cow, we've got a whole bunch of terms there that need to be combined for the final area. Final area here is going to be 21x cubed. It's the only x cubed term. 35x squared. 15x squared. Negative 3x squared. Well, 35 and 15 is 50. 50 minus 3 is 47x squared. We then have 21x, 25x, negative 1x, positive 9x. Well, here I got 21 and 9 is 30. 30 and 25 is 55. Minus 1 is 54x. And we're left with 15 and 3, which is plus 18. Whoo! Big, long calculation. be familiar with it. Will you get something that big on an assessment? Not necessarily, but a question a lot like it. There's nothing about this question that's unfair. It's just that we have a ton of multiplying occurring. Lots of parts. Lots of room for silly errors. So here's another shaded area question. We just talked about shaded area questions, so it shouldn't be too complicated. Again, for the shaded region, we want the area of the big shape, which would be this entire rectangle, length times width, and we want to subtract the unshaded part, which is a smaller rectangle, which would be length times width as well. Not a lot different. So do the calculations. Here it's just a monomial times a monomial and then subtraction. So that's a 12x squared. From there, I need to do FOIL. And doing FOIL means I want to subtract. Do the FOIL process, binomial times binomial. However, we want to subtract all of it. Make sure it's in brackets so the negative distributes to absolutely every term. So much going on again. As soon as you do FOIL multiplication, you get lots of parts. 6x squared becomes negative. Negative 12x, positive 2x, because a negative and a negative is a positive, and a positive 4. And now I combine my like terms. 12 minus 6 is 6, not 18. 6x squared, x and x, negative 10x, plus 4. And there's your solution. So all kinds of little steps, but understand it's no different when this was first introduced to you back in like grade 7. Area of the big shape, subtract area of the small shape. It's just we have different calculations. So with that being said, here's your assessment, or sorry, your assignment. Booklet, page 26, give it a try. Please note that 3C should have these ticks on them, which will make it a question. Otherwise, you couldn't do the question. So take note of that. The answer for 3C will be x squared plus x minus 12 if you do it correctly. That's it. That'll bring polynomial work to an end with the multiplying and combining and putting stuff together. Next lesson is we start to take it all apart. Factoring. Whew, it's good stuff. Have a great day.